Hello, this is Mr. Huber. In this lesson, we're going to learn about solving absolute value equations. Now, if you recall, an absolute value is the distance a number is away from zero, right? So absolute value, and it's marked these little bars here. This means absolute value of x is equal to 9. So we want to know any numbers that would be a distance of 9 away from 0. So 9 would be, but so would negative 9. If this is 0 and this is 9 on our number line, and on this side this is negative 9, both these numbers are a distance of 9 away from 0. The distance from negative 9 to 0 is 9 units. The distance from 0 to 9 is 9 units. Right? Distance is always positive. It doesn't matter if I measure from 0 to 9 or 9 to 0. The distance is 9 units. Think about how far you are away from something in the room you're in right now. If you want to measure that distance, it's not a negative distance depending on which direction you make the measurement. Okay, so absolute value is a distance away from 0. It'll always be a positive value. So absolute value of x equals 9 has two solutions, 9 and negative 9. If I put a positive 9 in here, the absolute value of 9 is equal to 9. If I put a negative 9 in here for x, the absolute value of negative 9 is still equal to 9. So both those values will solve that equation. And there's a few different ways we could write it. You could write negative 9 comma 9, no parentheses around it. It's not an ordered pair. It's not an x comma y. Okay? Or you can use this symbol for plus or minus. If it's the same value, one positive and one negative, this means x is equal to positive 9 and also negative 9. So there's three different ways you can write that. Write them out as each separate solutions. X equals 9, x equals negative 9. X equals negative 9 and 9, the comma between them, or plus or minus 9. Right? And an absolute value equation is any time we have an absolute value expression equal to a positive value. Okay, so we see that right over here. Right? The a and the b could be any values. Okay? And the absolute value of whatever this expression is equals c. C has to be greater than or equal to 0. Right? We can't have an absolute value equaling a negative because absolute value is always a positive distance from 0. So this is saying that we could take ax plus b and find out when would that be equal to c, or we could take ax plus b, this absolute value expression here, and set it equal to negative c, just like we saw with the absolute value of x equaling 9 and negative 9. The key here, a couple things, you have to isolate the absolute value expression. Okay? So we have to get rid of anything outside the absolute value expression. We want to get it so it looks just like this. Absolute value, anything you want inside there, but nothing outside of it on that side of the equal sign, equaling a positive or 0. Right? So first get the equation in this form, that absolute value equation form. Then we'll set up our two equations and solve them both to get our two solutions for x. So when we have absolute value of r minus 7 equals 9 in this example here, this is our absolute value expression all by itself, right? This is ax plus b equals c, right? So r minus 7 equals 9, would be one of our equations. And then we would take r minus 7 equals negative 9. And that would be our second equation. We solve both of those, so we're going to add 7 to both sides here. So add 7, right? To cancel that out and get r equals 9 plus 7 is 16. We add 7 to both sides here, and we get r equals negative 2. So we can see it's not always like plus and minus 9. It can be two different values, like we see here, 16 and negative 2. And if we want to check those, what can we do? Just like any time we want to check a solution, plug it back in the original equation. 16 minus 7 is 9. The absolute value of 9 is 9. I plug a negative 2 in here. Minus 7 is negative 9. The absolute value of negative 9 is also equal to 9. So we have two solutions for that equation. R equals 16 and R equals negative 2. As we see some more absolute value equations to solve, again, keep in mind that very first important thing, we have to get the absolute value expression by itself. So we need to add 5 to both sides here, right? We're trying to get this expression right here by itself. That's like our x, if you will. So as we try to get that part of the expression, the equation by itself, the absolute value expression, right, we'd add 5 to both sides. We'd have 4 absolute value of t plus 9 equals 24. And now I want to divide by 4, right? Just like if it was a 4x, I'd divide by 4 to cancel out. I have absolute value of t plus 9 equals 6. And now I can set up my two equations. I'd have t plus 9 equals 6, and t plus 9 equals negative 6. And I solve these by subtracting 9 on both sides. I get t equals negative 3. Subtract 9 on both sides here, and I get t equals negative 15. Those are my two solutions for t. So you can get the absolute value expression by itself. Again, if we look in this next one, if we wrote this like 3, and I'll use y, so we don't think it's something like the x there, plus 22 equals 4, right? We would be saying, okay, how do I go about getting that absolute value expression by itself, right? The same as I would getting the y by itself, right? So to get the y by itself, I'd subtract 22 and divide by 3. I'm going to do the same thing with the absolute value part. I'm going to subtract 22, and I'll have 3 absolute value x plus 7 equals a negative 18. And now when I divide by 3 on both sides, I get absolute value of x plus 7 equals negative 6. Remember, I want to get the absolute value by expression by itself. That's the ax plus b equals c. One thing that we also pointed out in that c has to be greater than or equal to 0. Since it's not, this is negative 6, this absolute value will never be equal to negative 6. I don't care what number you plug in here for x, it's not going to work. If you tried to solve this and you got some value, like let's say negative 13, and you plugged a negative 13 in here. Negative 13 plus 7 is negative 6. When I take the absolute value of that, it's going to be 6 equals negative 6, which is not true. So this is never going to be true. So there'd be no solution. Okay? Your absolute value expression, when it's by itself, cannot be equal to a negative. It has to be 0 or something greater than 0. So in this next problem, we can see equals negative 8. That's fine. We haven't gotten the absolute value expression by itself yet. So first we need to add 23. Add 23 to both sides, and I have absolute value 3x plus 15 equals 15. Now I can solve this because I have the absolute value expression by itself equaling 0 or a positive, in this case a positive. So I can get my two equations. I would have 3x plus 15 equals 15, and 3x plus 15 equals negative 15. Now I'm going to solve both of these. I subtract 15 on both sides. That gives me 0. I have 3x equals 0. Divide by 3, and I get x equals 0. Subtract 15 on both sides here, and I get 3x equals negative 30. Divide by 3 on both sides, I get x equals negative 10. So 0 and negative 10 would be my two solutions for that equation. So get the absolute value expression by itself, make sure it's equal to 0 or a positive value, then set up your two equations to solve for your values of the variable. All right, before we see some more absolute value equations, little tocino trivia. If you know any Spanish, tocino is Spanish for bacon. All right, so bacon trivia. Which of these items doesn't exist? I mean, so many bacon items out there. Many of them are terrible as well. Bacon salt's pretty good. Some of those other ones, the bacon flavor on things is quite trash most of the time, pretty fakey. So any of those that you think might not exist, you're wrong. They all exist, including bacon soda, which I actually tried. Also pretty awful. Not very thirst quenching. I wouldn't recommend it. But bacon mince, bacon gum, bacon all at the Thai. Yeah, you got it. They make a bacon about everything. All right. Let's talk about absolute deviation. This is when we see absolute value in the real world. Something called absolute value, absolute deviation, also referred to as absolute error sometimes. So it's the amount that we can be off from a targeted goal, right? So the way we calculate that is absolute deviation, so the amount we're allowed to be away from our goal is equal to the absolute value of x minus the given value, all right? The value we want to have, right? The target. So the given value would also be considered the target or the goal that we're looking for. So in this case, we want to find the absolute deviation of x from 7.6 is 5.2. So the absolute deviation is 5.2. That's going to be 5.2 equals absolute value x minus 7.6. Right? The absolute deviation is 5.2. We want to find out what values of x would make this true. So now I've got my absolute value expression by itself. I can set up my two equations. X minus 7.6 equals 5.2. x minus 7.6 equals negative 5.2. So now I can add 7.6 to both sides, and x equals 12.8. I'm going to add 7.6 to this side. Okay, I'm going to get x equals 2.4. So those are my two values for x that would work there. And we're going to see a next example of where absolute deviation is useful in the real world, because not everything has to be exact. Maybe you're manufacturing something, like thinking about a desk maybe you're sitting at, and the desk needs to be a certain width. Well, the manufacturing needs to be off a little bit, so there may be like, a tenth of a centimeter they're allowed to be, above and below some targeted amount. So that's where that absolute deviation can come in, where we say, okay, there's a little bit of error, absolute error, that we're going to allow a little bit on both sides of whatever we're targeting. So we see that in an example here of a basketball, at the basketball game. They want to be filled to an air pressure of 8 psi. Well, it might not always be exactly 8 pounds per square inch, so they allow it to be a little bit above and below, a little underinflated or overinflated. So there's a range, though. They don't want to be completely overinflated or underinflated, but there's a little bit of margin there where they know it's not going to always be exactly 8. So an absolute error allowed of 0.5 psi. So again, it can be a little bit above or below. So that absolute error, okay, is equal to x minus the targeted amount, right? What are we aiming for? We're aiming for 8 psi. And so we could figure out what's the allowable low and high end that basketball could be. So I can set up my two equations. 0.5 equals x minus 8, and negative 0.5 equals x minus 8. My absolute value expression equal to the positive and negative value there. So I add 8 to both sides here, and I get 8.5 equals x. I add 8 to both sides here, and I get 7.5 equals x. So the acceptable minimum would be 7.5 psi up to 8.5 psi. As an inequality, we could write it 7.5 less than or equal to x less than or equal to 8.5. Right? So we can have anything from 7.5 to 8.5. If they check and it's 8.8, not allowed. It's too much. If it comes out to 7.8, great. That's in that range that's allowed. So absolute deviation, also called absolute error, is an amount we're allowed to be away from some targeted goal. And that's where we can use absolute value in the real world. Remember, get the absolute value expression by itself, nothing outside of it on that side of the equal sign. Anything inside of it we'll take care of when we set up our two equations, absolute value equaling c and negative c, or whatever that value is. Make sure it's 0 or positive before you set up those two equations, and then solve them as you would any other type of equation.